Hey everyone, welcome back to our FEA tutorial series. If this is your first time here, my name is Carson and I'm a senior on Chico State's SAE Baja team. I have something pretty cool to show you called Design Optimization, which is a tool in SolidWorks simulation that lets you iterate your design to find geometry that best fits your design goals. So let's put a backstory on this one. Let's say you need to design a brake pedal for your team, so you come up with this. Since you already know how to do a bit of FEA, you've already set up a study and analyzed what will happen when the driver hits the brakes, right? So that's what we have here. Just a basic static study. Everything is running how it should. We have results, okay? Factor of safety. Mesh is already refined, okay? If you don't know how to get to this point, watch the 3 videos before this one, and they should set you up pretty well. But I can't stress it enough, you need to actually have a working stress model before you can do a design optimization. Otherwise, you're not going to be able to optimize anything. That's just not how it works. Okay? So now you take this to your system lead and you show it to them. Or if you're the lead, you bring it to someone higher up for review. Then they take a look at it and they're like, okay, looks like it should work. But then they tell you to pull up the mass properties. They say, okay, 0.3 pounds, that's a little chunky. Now let's look at your factor of safety. What do we have there? 4.55. Wow, okay, that's a little overbuilt. For driver controls, we designed to a factor of safety of 1.8 or higher, right? But your design has a factor of safety of 4.5. So come back with something a little lighter that still passes stress analysis. That's when you go back to SolidWorks and you start a design study. So to do that, make sure you're on the Simulation tab. Drop down the Study button here, New Study. And I know you haven't played with these yet, so here we go, Design Study instead of Static. You hit OK, and it starts it up there for you. So now you have this sort of drop-down menu kind of thing here. This is where you input the guts of the design study. You have variables, constraints, and goals. So that's what you need to know coming into your design study. Variables are things that can change in your model. So let's say dimensions. All right. So this whole dimension, I think that can probably go up or maybe even go a little smaller. I'm not sure. Whatever the computer wants to do to optimize it. So you have to give it dimensions that it's allowed to vary in order to optimize this part. Okay. Constraints are the limits of the optimization, right? So if I want a factor of safety of 1.8, I can go ahead and set a minimum factor of safety of 1.8 and let the computer figure things out. Goals, in this case, we're going to try and reduce the weight. So let's go ahead and add these in. So I already have variables predefined in this, but if you don't already have these here, which you won't, you go to Add Parameter, okay? And up here, you see the ones I've already created, but otherwise you go here, type in your name, and then go click on a dimension, okay? So you see the dimension there populated. Now you can put that in here. I'm going to cancel this so I don't keep that. You can put that in there, and it's going to let the model try and optimize that. So let's put these ones in that I have right now. So width, thickness, and the hole, okay? There's several options to optimize it. So range with step is where you put in a range of dimensions that you're going to let the system run to with an increment, okay? Otherwise, there is discrete values, or if you want clean numbers, you can go ahead and do that. Or range. Range is a little different. You put a min and a max. You don't put a step size, and what it does is it runs a few different scenarios between this, and then it's going to use SolidWorks magic and actually interpolate what it thinks is the optimal result. Okay, so you might get some crazy numbers. If you're using the CNC, no big deal. If you're machining it by hand, you maybe want a little bit cleaner numbers. So I like to go with range with step. Okay, and let's go ahead and put some limits on this. So for this one, minimum, I'm going to say 0.25, maximum 0.75, which is what it's already at, with a step size of 0.1, thickness, same deal. I'm going to do 0.5 up to 0.75 that it's already at. Step size of 0.1. So I'm going by 0.1 because that's easy to work with. You can machine to 0.1 by hand, no problem. Okay, the hole diameter, let's say we have 1/8 inch increment drill bits. They're pretty easy to come by. So let's vary the hole from 0.5 that it is right now, and I'm going to let it go up to 1 inch maybe, okay? And increment 0.125. So you can see here, with this combination of variables, it's going to have 120 scenarios. So that means it's going to run 120 stress simulations, all right? So this is going to take a little bit of time. Right now it's not ready to run. You can see the run button is grayed out because it's not going to know what to do. It's just going to start running with no purpose in life. Okay, so you want to add a constraint. All right, so let's go ahead and add a sensor. You can see these are ones I already did before. Add a sensor. Sensor type. These are your options for that. So you can pull from mass property, simulation data, dimension measurement, etc. Let's go ahead and do simulation data because I want to make sure our factor of safety stays above 1.8. So inside the simulation data, you can set all of these as constraints, okay? But I'm going to set factor of safety, model max, yeah, okay, that's okay. Hit okay, and there you go. Right now you can make it less than, greater than, is between, just keep track of it. Okay, so I'm going to say is greater than 1.8 because that's what our threshold is basically. Okay, so now it's going to run, and anything that comes up with the factor of safety of under 1.8, it's going to drop out of consideration. Goals, like I said before, you do the same thing, add a sensor, but we're trying to minimize the weight. So with materials that, steel, aluminum, there you go, mass, volume, they do the same thing. Okay, mass, I'm sorry, I'm going to go back to that, delete that. Make sure that you click on the model, there you go, mass, and you have some options. So minimize, maximize is exactly, so you can try and get it exactly to some magic number. In our case, we're just going to say minimize. All right, so now your design optimization is set up. You have things that can change in the model. You have 3 dimensions here. In this case, it's not a whole lot. You can add more, but you see 120 scenarios. That's already going to take a good amount of time. If you're wanting to do a final optimization on this part and you're really confident that you're not going to crash your system, then you can go ahead and add a bunch of variables on there and get it really nice and optimized. Okay, your constraints, like I said, factor of safety, minimum of 1.8, and you're going to minimize the mass. So now it's set up, and you can go ahead and hit run. Make sure to save your file before you do this, all right? I've already done this, so I'm not going to save it, but be sure to save it because you don't want to crash and lose all your setup. So let's go ahead and hit run. Okay, yeah, look at that, 120 scenarios. It's going to take a while. That's okay. You can change it to fast, but then what it does is, I don't really know what it does. I tried it once, and it went fast, but it didn't really optimize it that great. So let's go ahead and take the full time. All right, so it's going to start doing its thing. And you'll see in the graphics window up here, it's going to actually do a live update of what it's doing. Okay, if my computer doesn't freeze up, I might actually let you see some of that. Let it keep thinking. Okay, there we go. So now right here you get a table with all the scenarios, and it's going to start running these. And you can see, well, I'm not going to try and scroll right now. Oh, there we go. It started changing it, so it shrunk it down. It changed it to these dimensions, and it got a factor of safety of 0.57, and that didn't work. So it moved on to the next one. Well, it'll keep moving on to all of them, even if it finds one that's pretty good. It's going to go through all of these until it's done, and then when it is done, it's going to tell you what it thinks is the optimal iteration, basically. Okay, so just like on a cooking show, I'm going to skip this whole part, and we're going to go straight to the end. Okay, that got finished running. It took about 20 or 30 minutes. I didn't really keep track, but you can see here down at the bottom, it ran through all 120 scenarios there, and it found what it thought was to be the optimum. So you can click on right here. You can see it's in a green box, the optimal. And you can see it decreased the width to 0.35. Thickness stayed the same. Hole diameter got bumped up. Factor of safety is down to 2. All right, not quite down to the 1.8 that we set it to, but that's all right. And the weight got cut a little more than in half, so 0.14 as compared to the 0.3 that we had before. So that's pretty good. Now, if you wanted to optimize this a little bit more, you could maybe add a few more geometry factors, right? So this pocket width, you might be able to increase that. There's a few things you can add on here that would take a lot more time, but if you were really wanting to cut every single gram out of this, then you can go for it. Now, the cool thing about this, since it ran all those stress calculations, is that if you come over here, we see you have your goals, right? So there's your factor of safety plot, 2.05. We had it filtered off at 5, so that's just how we left it. But if you want to see everything else, you can go back to your static study, and it keeps that geometry, okay? So it updates your part geometry unless you decide to go back to the initial. So all of these stress parts, or stress files, are going to show your results with the new geometry. Okay, so then you come over here, displacement, make sure everything's good there. And if you want, you can just go back to model and keep working. This is your model now. You don't have to change anything back. So this design optimization is a really great way to save yourself some time. It's also a great way to waste yourself some time. So in this case, it's a fairly simple part. Could you have iterated by hand and gotten pretty close to this result? Yeah, probably. But if you have something a little more complex and you're not really sure where to start taking weight out, this is a great place to start. But you do have to do quite a bit of setup work beforehand. So it's kind of a balance in your engineering discretion to see if you want to do this. Something interesting to note is that if you come over here and look at your minimum factor of safety, you can see there are some cases where the factor of safety got down closer to your goal. So like right here, you have a factor of safety of 1.9. Okay, that was closer to 1.8, but it actually ended up being heavier than the optimal that it found with a higher factor of safety. So you actually ended up with less weight and a higher factor of safety than you might have landed on if you were just trying to optimize this yourself. So that's when the computer comes in handy. If you thought this video was helpful, give it a like and let me know in the comments. Let me know if you'd like to see anything in particular as far as SOLIDWORKS simulation goes, and I'll try and get a video up on it. Until next time, have a good one.